Hello everyone and welcome to MV Tutors. I'm Tsulu and I'll be going through the memo with you guys. My husband will be joining a bit later, or maybe not, we'll see. Maybe I'll just record straightforward, okay? But yeah, let's look at the paper that was written this month in May. It was written on a Friday. So I hope those that were writing, you guys wrote well. I also hope paper 2 went well. And for the metrics that are going to write in June, I hope this will help you prepare. And also for those writing in November, I hope that you are going through this as well as a preparation, as a way of preparing. Okay, so let us get to it. But before we do, please don't forget to like our videos and also subscribe to our channel. And please share this with your classmates, anyone that you know that is in matric, anyone that you know that is still going to rewrite in November, because this is valuable information. Okay, let us get to it. So, question 1, we are solving for x, okay? And our first question, 1.1.1, it is x squared plus 2x minus 15. Okay, so in a case like this, it's equal to 0. I would want to know what the factors of 15 are and see if I can get 2 out of those factors. Okay, so this is something you do on the side. So 1 times 15 will give me 15. 2, it doesn't give me a whole number. 3, yes, I can multiply it with 5. And that pretty much is that. Okay, so I know that if I take 5 and subtract 3, I can get 2. So we're going to go ahead with that. All right, because I need to get a positive 2. So that'll be plus 5, and I need to get negative 3, because plus 5 minus 3 equals to positive 2. And plus 5 times minus 3 gives me negative 15. So at the end, x is equal to minus 5, or x is equal to 3. Okay, I'm not going to write out x plus 5 is equal to 0, hence x is equal to minus 5. You already know this, you're used to it. We can move on. Okay, and now 1.1.2, as soon as they say leave your answer in two decimal places, okay, then you know you're going to have to use the quadratic formula, all right? Don't even bother trying to find the factors of 5 and 9 and all of that. No, let's just go straight to the calculator. Okay, so what does the quadratic formula say? We have minus b, okay, plus minus, and b squared minus 4ac, and all of that is under the square root, and then it is over 2a. Okay, so what is our b at this point in time? That will be negative 1. Okay, don't forget your brackets. Okay, so we have negative 1 squared minus 4. Our a is 5. Our c is negative 9. And then all of that is under the square root. So 2 times a, which is 5. So we're going to just pop out our calculators and work it out. Okay, so we have our fraction there. Okay, minus 1. Oof, what am I doing? Minus 1. I know in this case you could just write 1, but yeah, I just want to put things as they are in the calculator, and not try to calculate things in my head, because that's when stupid mistakes are made. Okay, so just put everything as it is in the calculator, or whatever it is that works for you. Okay, I know sometimes I'll be thinking too much and then I write the wrong things. Okay, so one of the answers, we have x is equal to 1,44, or no, let us round it off to 2 decimal places. Yes, 1,45. Okay, or x is equal to, if we put a negative there, okay, it'll be negative 1,25. Okay, so that was not bad. For those who are going to still write exams, please learn and practice how to do these questions fast. This is where you should be getting your marks and doing things quickly, because other questions are still coming that will require you to think and pause a bit. Okay, so where you can be fast, be as fast and accurate as possible. Alright, and then we have x squared for 1.1.3 smaller and equal to 3x. So whenever I have inequalities, it's just like with solving for x, you just want to put everything to one side, right? So then we have x squared minus 3x smaller and equal to 0. Okay, x squared, we have a quadratic function. Alright, so now we need to get what the factors are. Okay, not the factors, but more of your x-intercepts. Okay, because with this kind of question with inequalities, I like showing it on a sketch just to see what's happening. Alright, so x squared, we have so far a happy face parabola, and we need to find out what the intercepts are. Okay, so I can take out a common factor, which is x, and then x minus 3. So I know that my x-intercept would be 0. I just want to say and, because those are the intercepts, and x is equal to 3. Okay, so I can put there 0 and 3. But where does the solution lie? Okay, so if it's smaller and equal to 0, it is in this region over here. Okay. If it was bigger and equal to 0, it would be above the x-axis. Okay, this is our x-axis. So your y values are positive here, your negative y values are, or your y values are negative in the bottom. Okay, so if it's smaller and equal to 0, we're looking at a solution here. If it was bigger and equal to 0, we would have solutions there. Okay, so that is how I use the sketch. But yeah, so when I finally write my solution for x, okay, I know that x is in between 0 and 3, and it is equal to as well. Okay, so that is the answer. And then we can go over to 1.2. 1.2, where we have that a plus 64 over a is equal to 16. And then we are asked to solve for a in 1.2.1. Alright, so I am going to put the 16 to the left side. Alright, so a plus 64 over a minus 16 is equal to 0. Then I don't like using fractions, so I will multiply by a throughout. Okay, so I will have a squared plus 64 minus 16a. Okay, I'm just going to rearrange it in a form that I'm used to. So it will be a squared minus 16a plus 64 is equal to 0. And then we can solve for a. Okay, in this case, it's up to you whether you want to use the quadratic formula or you want to use factors. Okay, so I'm going to go with the factors one. So I have 1 and 64, 2 and 32. They don't give me 16. 3, no. 4 and 16. Let me check on the calculator. Okay, so this is what can waste time when you use the factors. Okay, 4 and 16. They're not giving me minus 16. Is there 6? I don't know. I don't know if 6 is a factor. No. 8. Oh, yeah, so I have 8 and 8. Okay, for a moment there, I thought I'm going to have to use the quadratic formula. Okay, so I have a minus 8 and a minus 8. Okay, and then our answer would be a is equal to 8. I'm not going to say or a is equal to 8. It's just 8. Let's just leave it there. So we have solved for a. And now 1, 2, 2. Hence, solve for 2 to the power x. If it says hence, then there must be a relationship there's a relationship between this question and the previous one. Okay. So I see, what relationship could I have? I see, I have 16, right? We have 16 over here. We had 16 there. I have a 2 to the power x. Okay, let me see how I can unjumble this equation such that it sort of like looks like the previous question that we had. Okay, let's see. I want to bring 16 to the other side. All right. So let me see. This one is as simple as can be, 2 to the power x, but 2 to the power 6 minus x. I can have 2 to the power 6 times 2 to the power negative x. Okay, that's how I can separate it, if so to say. Then I can bring 16 to this side. 2 to the power negative x, I am going to write that in fraction form. Okay, so this is 2 to the power x. Then I have 2 to the power 6 divided by 2 to the power x. Okay, and I have minus 16 is equal to 0. Does this look in any way familiar? I don't know. Let's continue. So I want to get rid of that fraction, so I'm going to multiply by 2 to the power x. All right. So I have 2 to the power x times 2 to the power x. I'm left with 2 to the power 6. What is that? Let's just check. 2 to the power 6 is 64. Okay, so I have plus 64. And then I'm going to have negative 16 times 2 to the power x is equal to 0. Are we looking anything? Okay, I think I want to look like, I want this sum to look like that so that I can use the hence. Okay, yeah, so let's have that. Copy, and let's put it next to, what we're doing so that we can see what is familiar here. All right, so I can have 2 to the power 2x, right? Because if you have the same base, you can add your exponents or your powers. So I have 2, okay, to the power 2x. And then I have minus 16, all right? Yeah, minus 16 times 2 to the power x. Okay, let me put it like this rather. Let's just do this. 2 to the power x squared. So yeah, and then I have minus 16a. Okay, just bear with me. I will show you what I'm seeing. I hope you can see it too. So basically, if I were to say, sorry, let me just shift this a bit downwards. Okay, if I were to say, let let a equal to 2 to the power x, or rather let 2 to the power x be a. Okay, then I have this sum over here. Okay, because 2 to the power x is a, so I have a squared minus 16a plus 64. And what did we know about a? We knew when we solved it, right, that a is equal to 8. So what can I do? I can say 2 to the power x is equal to 8. And then I can solve, right? We can solve for x, definitely. So 2 to the power x is equal to 2 to the power 3, because 2 to the power 3 is 8. And then at the end, x is equal to 3, and we're done solving. Okay, yeah. Guys, you could have really solved this sum without having to relate it to a, but it would have wasted time, and this is 3 marks. Okay, I know I did it in a lengthy way. Some of you could have seen it much earlier, some of you maybe didn't see it, but just watch it again just to see what I did. But I hope it makes sense. If ever you have a hence, it means the 2 questions, the one you're busy with and the one you did previously, they are connected. Okay, so don't solve from scratch again. Try to connect them. Okay, cool. And now we get to 1.3. Are we almost done with question 1? Kinda. We are. The mark says we're still a long way to finishing. Then it says, without using a calculator, calculate the value of that big sum. So we have 2 to the power 1002. Okay, plus 2 to the power 1006. I know most people have trouble doing these questions because it's like, my goodness, we have so much to work with, such big exponents. Why are they doing this to us? But please do not fear when you see such questions. I would advise, take out the common factor when doing these sums. Okay, either take out the common factor on top and on the numerator, and then make the denominator work. Ooh, sun is coming out. Or look at your denominator, okay, and try to make your numerator somehow equal to your denominator. All right, I like taking out the common factor, so I will start with that. So on top, on the numerator, I can take out 1002, 2 to the power 1002. So I'm left with 1 here plus 2 to the power 4, because 4 plus 1002 will give me 1006. Okay. And then in the numerator, well, I can just put 2 to the power 998 to the side, and I have 17 there. So I hope you see it, but if you take 2 to the power 4, it gives you 16. Okay, and 16 plus 1 is 17. Ooh, forgot the square root. It is 17. So I know on my numerator, I have 2 to the power 1002. And I have 17. And at the bottom, I have 2 to the power 998. And I have 17 as well. So things are looking good. Cancellations can be done. So we can cancel out the 17. Alright. Then we are left with 2 to the power 1002. And I'm just going to subtract 998. Because that's what you can do if you have the same base, okay, and you are dividing, you can subtract the exponents, okay. Let's not forget the big square root over there. So 1002 minus 998, it looks like an easy thing to solve, but I'm going to use the calculator because, wow, I don't want to make a silly error. Okay, 2 to the power 4. Alright, and we know that 2 to the power 4, really, that's 16, okay. And we know that 16 squared, that is 4. Alright, and that's how you do 1.3. Now let us look at 1.4. Simultaneous equations. So we're solving for x and we're solving for y. So far, this paper it's nice. I hope the June paper for the matrix is also this nice. Okay, so I am going to make the subject of the formula, for the first equation. I'm going to make y the subject of the formula. So I'm going to take y this side, and I'm going to take 2 this side, okay? So if I do that, let me just do it as I'm saying. I'm going to have 2x minus 2. So basically that is what y is, okay? I'm going to make that my first equation, and that is my second equation. So I'm basically going to substitute my first into my second. Okay, and what does that give us? Alright, before I even go far, if I look at my second equation, let me just simplify that a bit. I don't like working with fractions, so I'm going to multiply with x throughout. So then I'm going to have 1 minus 3xy is equal to x. Okay, so that is basically my second equation. Alright. So, I'm substituting y into the second equation, or I'm substituting my first equation into my second equation. So I have 1 minus 3x, and in the place of y, I would put 2x minus 2. Okay, and all of that is equal to x. Alright, so I'm going to just take the x to the left, to the left, to the left. Okay, 1 minus 6x squared, alright, and then plus 6x. Now, when you solve simultaneously, you can make silly mistakes, so let's just make sure we're doing the right thing. And then we are subtracting x, and it's going to be equal to 0. So I have negative 6x squared plus 5x plus 1. plus 1 is equal to 0. I'm just going to multiply by -1 throughout. Okay, you don't have to. I just like working with a positive x squared. Okay, so I have minus 5x minus 1 is equal to 0. Here you can use factors. I'm not going to do that. I'm just going to go straight to the quadratic formula. So x is equal to minus 5 plus minus 5 squared. Okay, it's b squared minus 4ac. Okay, all of that under a square root. Yeah, I'm sure you're wondering, why do I always have my head tilted? I'm left-handed, so I just write like that. Okay, so yeah, we're gonna just put this in the calculator and solve. Okay, so I have mine. Okay, I'm just gonna put plus 5. And then we're starting with the positive option. So I have 5 squared, that's 25. I know in the previous question I said just put things as they are, but I just want to get this question done. Okay, so I have 1 as one of the options. So x is equal to 1, or, you know what I haven't been doing this entire time? I haven't been checking if the answers are actually working, and that is what you should do when you solve for x. Okay, x is equal to negative 0,167, or rather 17. But this, can I just check something? If I say 1 divided by 6, yeah, so I'm just gonna say -1/6. Okay, yeah, so what I've been saying is I've been calculating, but I never checked if the answers are actually correct. And I'm only checking now. This will take time, but yeah, I think I'm gonna pause and check if really x is equal to -5 and 3 and 1,45 and -1,25 and all of that, because in all honesty, guys, sometimes not all the solutions are correct. So let me just finish off with this question. Then I will pause and then check everything so that I don't waste your time. And then we can really see if, these answers are really working out. So we have our two x values. X is equal to 1 and -1/6. Now we're looking for the y values. And I'm going to use my equation. Y is equal to 2x minus 2. Okay, y is equal to 2x minus 2. So if x was 1, so I'm going to say 2 times 1 minus 2. So that's just going to be 0. Okay, so y here is equal to 0. And in this case, I have y is equal to 2 times -1/6 minus 2. I am putting that in the calculator to save time, because this is the one section where time really can be saved. Okay, negative, and then minus 2. Okay, so -2, 3. I think that can be -2 1/3. Okay, yeah, -2 1/3. Or what can it be simplified to? 2 times 3. Oh, 7/3. Let's see, 7/3. Yes, -7/3. That's the other solution. Okay, so I'm gonna pause now. We're done with question 1. We'll be done only if, as I check that the answers are valid. So I'm gonna pause, check all the answers, and then get back to you now. Okay, so I did have a look, and yeah, everything seems to be in order. When I checked this -1,25, I got a very, very small number. So it is kind of, you could say it's negligible. So it does give you 0 at the end. So I will take that. But everything else seems to be working fine. So lesson learned here as we complete question 1 is, once you have solved 4x, don't be like me and be in a hurry to finish, but check your answer. Plug it back into the equation and make sure that it gives you either 0 as question 1.1.1 and 1.1.2, or either 2 and 1 for solving simultaneously. Okay, so that's it from me. I'll see you again in question 2. Yeah. Hello everyone and welcome back to NB Tutors. I'll be continuing with you guys for question 2. So yeah, let us get right into it. So we have a first term of an arithmetic sequence that is equal to 1, -1, and the 7th term is equal to 35. Alright, so now we need to determine the common difference of the sequence. So basically looking for D. Okay, so we have the first term. It's nice that they gave us the first term, so we can definitely use our arithmetic series formula. If you're not sure what it is, you can go look in your formula sheet. It should be given. So I'm going to look at the 7th term, right? Because I know that I have the first term, which is -1. Alright, and I know that's going to be 7 minus 1, and D is what I'm looking for. So the 7th term, they gave it to us, it's 35. So minus 1 plus 6D. If I take 1 to the other side, I'm going to have 36 is equal to 6D. And if I divide by 6 on both sides, I will have that D is equal to 6. So the common difference there is 6. Alright, let's go to the next question, 2.1.2. The number of terms in the sequence. Okay, so we need to determine the number of terms in the sequence if the last term of the sequence is 4, 7, 3. Okay, so yeah. We will be using our term equation. Okay, a plus n minus 1 d. Okay, so it says the last term of the sequence is 4, 7, 3, and we want to know what number that term is. So we have our first term, it was given, it's -1, and we are looking for n. In this case, we know that d is 6. Okay, so we are basically solving for n. So if I take -1 and 6 to the other side, it will be 4, 7, 3 divided by -6, and then I have n minus 1. So basically n is -4, 7, 3 over 6 plus 1. And guys, in this case, you cannot be getting a fraction of n. It should be a whole positive number. So if we get a fraction here, then I did something wrong. Okay, we have -473 over 6, and it does look like I did something wrong. My goodness. No, it is 473. Okay, let's calculate. What am I doing now? Let's calculate. Okay, so -473 over, oh yes, I did something wrong. Yo guys, okay, there's absolutely no way I was gonna get a whole number, so I forgot the 1. Okay, so if I take -1 the other side, I will have 474, right? And if I divide by 6 both sides, I will have n minus 1. Then n would be 474 over 6 plus 1. Okay, now I feel a whole lot better. So divided by 6, yeah, there is no negative. Let me just start over. So I have 474 divided by 6 plus 1. Okay, and that is 80. It's a whole positive number, and I am happy. Okay, so if I were to take 80, substitute it into the equation, I should be getting 473. A check that you should do. Alright, and then 2.1.3, the sum of the first 40 terms in this sequence. Okay, remember for the sum formula, you have that one that gives you the first term and the last term. We have the last term, we can use it, but for the sake of time, I'm going to use what we normally use, 2a plus n minus 1d. Okay, the sum of the first 40 terms, so I'm looking for S40. But we could also use that, right? Sn is equal to a plus l over n. Is that what it is? Let me just check in the formula sheet so that I don't lie to you guys. If it is given, no, they don't give it to us. Okay, I don't have my textbook with me, so I'll just let it go. This is 2.1.3. Okay, but I think it was a plus l over n. I don't know. Anyway, we have 40 over 2. Our first term was negative 1. Okay, so we have 40 minus 1, and our common difference was d. Okay, plug that into the calculator. So we have 20, and then we have negative 2 plus 39 times 6. Okay, 4640. Out of interest though, does this one work? If we were to have the first term as negative 1 plus the last term, which was 473 all over 40. Hey, no. I must have written it incorrectly. Yeah, something is missing in this equation. Forget I said anything about that, but yeah, something was. Oh, I think it is. Sorry guys, you can definitely skip. I think it was n over 2 and then a plus l. Now let's see. N over 2. So n 40 over 2 and multiplied by the first term negative 1 and the last term 473. Nah. Nope. It doesn't work. Never mind. Yeah, never mind. Sorry for wasting your time. Let's stick to what we know. 4640. Yeah, and then we go to 2,2. Alright, so we have a quadratic number pattern. Okay, when you're dealing with arithmetic series, think about a straight line. Okay, straight line function, cool. If you're thinking of a quadratic pattern, think about a parabola. Okay, if they ever ask about minimum, maximum, it's a parabola. So if you have that in your mind, things can get easy when it comes to answering. But let's write out our pattern. So we have 75, 53, 35, 21. Okay, and then they want to know for 2.1.1 what the fifth term is. Okay, so I am going to get the first difference so that I can eventually determine what the fifth term is. So what is 53 minus 75? I am not doing that in my head. So it is negative 22. Okay, and then what is 35 minus 53? It is negative 18. And then what is 27 minus 35? It is negative 8. Okay, so now if I go from negative 22 to negative 18, I would have to add 4. But if you're not sure, put in the calculator negative 18 minus negative 22, so that gives you 4, right? Again, okay, no, did I put the right thing? 27 minus 35, yeah, it's negative 8. So if I go negative 8 minus negative 18. I did something wrong here. 35 minus 53. Is 21. Sure, I'm putting 27. Okay, sorry about that. So 21 minus 35, that is negative 14. So negative 14 minus negative 8. Negative 14 minus negative 18, that's 4. So much. So I need to add 4 to get to the next term. So I'm going to get negative 10. And then I'm going to say, what is 21 minus 10? That is going to be 11. Yes. I'm not going to use the calculator. Okay, so we have 11 as our 5th term. Okay. Yes. T5 is 11. Now we go to 2.2.2. Determine the nth term of the number pattern. Okay, so we know if we're going to get the nth term, I'm basically concerned with the first diagonal column. Okay, and then what I'm going to do, I will start at the bottom there and say 2a is equal to 4. Therefore, a is 2. Then I would then go to 3a plus b. If you're not sure where we're getting the 2a, the 3a plus b, please check out our sequence and series lesson. I do describe that in full. Okay, so 3a plus b, that is negative 22. So a is 2, so I have 6 plus b is negative 22. If I take 6 to the other side, it will be negative 22 minus 6. So that's negative 28. And then I have a plus b plus c, which is equal to 75. Okay, so a was 2, b was negative 28, plus c, that is 75. So C is 75. Now 2 minus 28, that will give us negative 26. If I take negative 26 to the other side, it will be plus 26. And if we add that up, 5 plus 6 is 11, 9, 10. So 101. But let's just make sure, because we don't want to lose marks for stupid mistakes. So 101. Alright. So therefore, I can then write my term formula. So Tn is 2n squared minus 28n, right? Yes. Plus 101. Now when we get here, so while I was developing the memo, we have a tenant here who's upgrading and writing in November. So I told her, let's do it together so that we compare answers. And the one thing I forgot to do, my one error, is not check. So once you have your equation, check that it will give you your sequence. Okay, so in this case, our sequence is our number pattern 75, 53, 35. So let's just say we're looking for the third term. So I will then plug 3 in the place of n, okay, squared, minus 28 times 3 plus 101. And we get 35. And yes, 35 is our third term. How about our first term? Okay, just check 2 of them, just to make sure that, your equation at the end of the day is correct. So 75 is our first term. So we are confident that this is our quadratic formula. Okay, our pattern. Now 2.2.3. Okay, now it says determine the maximum value of the following number pattern. So now we have negative 15. And how many marks is this? This is what, 4 marks. So we're going to work, right? We have negative 15, negative 53 over 5, negative 7, negative 21 over 5. Okay, so while doing this, I noticed some similarities between this number pattern and the first number pattern. Okay, so if I go from 75 to 15, what would I have to do? So if I have 75 divided by negative 15, I need negative 5, right? So, sorry, let me just write down the original one that we have. And why am I doing this? I want to save time. I want to see what is the relationship between the two, because I'm not going to go all the way to get a new Tn equation by doing everything that we just did. But you can do that. You really can. If that's what you know and you're quick at doing that, please do that. I just want to see what is actually similar so that I can save time. Okay? But if you can't see anything, please, by all means, go wild by getting another Tn formula. And once you get a Tn formula, what you then do, you get your turning point, the x-coordinate of a turning point. And when you get the x-coordinate of a turning point, you can use this equation. But in this case, obviously, you have n instead of x. And after getting that, you're going to substitute this n value into your Tn formula to get what Tn is, which is what they're asking, essentially. I'm going about it a different way. I want to see what is the difference between the two. So I see if I take 75 and I divide it by negative 5, I get negative 15. Again, if I take 53 and divide it by negative 5, this calculator. If I divide by negative 5, I'm going to get negative 53 over 5. Okay, it's a setting I need to do in the calculator, but I'm not going to do that now. If I take 35 divided by negative 5, I'm going to get negative 7. So that's the trend here. So basically, for me to go from this Tn equation to that Tn equation, I need to divide by negative 5. Okay, so that is what I'm going to do. I'm going to take that previous Tn equation that we know is correct, we verified, and I'm basically going to divide by negative 5. Okay, so that I can get my new Tn equation. If you did it the long way, you would have gotten, answers there. I just thought, let me just do it a different way. Okay, that'll be plus 28 over 5n, and that'll be negative, what is 101 divided by 5? Oof, no, it's fine, I'll just use 101 over 5. So that is my new Tn equation, alright? And then, so we need to get the maximum value. Okay, so here, remember the various ways of getting the turning point. You can either use that equation I showed you, where it's going to be negative b over 2a, or you can differentiate. Okay, so I'm going to differentiate because for me, again, I'm trying to save time. So how do we differentiate? We're going to take the power, bring it down, and multiply it with the coefficient of n squared. So it will be 2 times negative 2 over 5. So that's going to be negative 4 over 5n. And then I have 1 over there multiplied by that. That will just be 28 over 5. And that will just be 0. Okay, and I make that equal to 0. So I don't like working with fractions. I'm going to take 5 to the other side. So I'm left with minus 4n plus 28 is equal to 0. And then 4n is equal to 28. So if I take 28 to the other side, it will be negative. So negative 4n is equal to negative 28. Remove the negatives, I have 4n. So if I divide by 4 both sides, I have that n is actually equal to 7. So 28 divided by 4, that is 7. But we're not done. We just got n, okay? We need to get now the value. So Tn, or rather T7, because we know what n is. Okay, where's our equation? We have minus 2 over 5, 7 squared, and then we have plus 28 over 5, 7, and then minus 101 over 5. Okay, we can put that in the calculator. So I have minus 2 over 5, 7 squared, so that's 49, plus 28 over 5 times 7 minus 101 over 5. Okay, so we get negative 0.6, which is negative 6 over 10. Negative 6 over 10. And how does this equation actually look? Okay, so if the coefficient of n squared, if that is a negative, we have a sad face parabola. Okay, so I guess then that is the maximum. So yeah, your turning point would be 7 and negative 6 over 10, or you can simplify to, if you divide by 3, negative 3 over 5. I think it's better simplified. Or you could just use the decimal, negative 0.6. I think anything would be applicable. Alrighty, so we are done with question 2. Don't forget to share this with a friend, with a classmate, okay? And don't forget to like our videos and also subscribe to our channel. Thank you. Hello everyone. It's a cold day on my side. Alright, so we're going to continue with question 3, and we can get right to it. Right? Let's not waste any time. So question 3, 3,1,1. We have a geometric sequence, right? If you think about a geometric sequence, think about an exponential function, right? Which starts off quite gradually and then all of a sudden, you know, it does that. And that's what we want with our money. We want our money to, you know, and then all of a sudden, because we want that soft life. But anyway, that is the geometric sequence. What we have there between the terms is a common ratio called R. And yeah, that's pretty much it. So we are looking for the 10th term of the sequence. I hope I remember this formula. If I forgot, we can always go back. But I think this should be it. So our first term is 1,024. Oh, we need to get the common ratio. Okay, so we have 1,024, 256, and 64. So what is 256 divided by 1024? That is 1 over 4, right? So basically we are multiplying by, or we're dividing by 4, but we're multiplying. So R is basically a quarter. Okay, because if I take 1024 multiplied by a quarter, I get 256, and if I multiply that by a quarter, I get 64, and you get the drill. So R is a quarter. Okay, and then n minus 1, they want the 10th term. So I'm going to just plug that in the calculator, and it will be 1024 multiplied by a quarter. This calculator is going to give me the answer in decimal form. So I think I should pause a bit and fix it so that we get fraction. Okay, anyway, to the power 9. So yeah, There should be a way. Ah, yes, there, I found it. So it is 1 over 256. I prefer brackets, fractions in this case, because you don't want to write, or you don't want to round off at this point. So yeah, and then 3.1.2, we have sigma notation. So let's just write it down, and let me just remind you what is, and yeah, solve it. So I have 256 for 1 minus p. So normally when you have sigma notation, what does it mean? It means that we want to get the sum, okay? So this is our equation, and we want to know what is the sum. If I take the first term, the second term, up until the end term, which I'm going to discuss now, and what is the sum of all those numbers? Okay, so with sigma notation, first thing, you want to know what your first term is, okay? At least have, 3 terms. That's what I normally do, okay? Then secondly, you want to know how many terms do you have in total, okay? Because they're not asking you to calculate up until infinity, all right? Nor do they give you the last term. So you need to know how many terms am I calculating exactly, and I'll show you how to do that. Then finally, you can then put your sum formula, because after all, sigma means the sum of, okay? So we need to know what the sum formula is for a geometric sequence. I think it's a r n minus 1. Yo, I'm thinking a lot, ne? I should be checking and not saying I think. I should be checking. So it is a r to the power n minus 1, r minus 1. And the condition r should not be equal to 1. So those are the basic steps that we're going to take when answering this question. Okay, so where is the sigma notation? There it is. Let me just make it a bit bigger. So now, the terms, okay? What are we going to start with? I'm going to use my equation, okay? And wherever I have p, I will first start by substituting 0, because we are starting at 0, okay? Another, if you don't want to use the formula, but I wouldn't even suggest this, I would literally go 0 up until 8. But that is going to take you forever. We are trying to save time with these easy questions. I know I'm saying it's easy, but for some it's quite tough. So yeah, let's not assume everybody finds this easy. Okay, and then the second term, I will then substitute the next one. What comes after 0? 1 comes after 0, so it's going to be 1 minus 1. And then again, my third term, I will say 265. No, when I know. 256. Okay, 4, 1 minus 2. Okay, and why do I do that? I want to get the value of r, okay? R could still be a quarter, but I'm not sure. I need to make sure, all right? So if I take my calculator and I say 256 times 4 to the power 1, that is just 1024. And then if I say 1 minus 1, that is to the power 0. So that is 256. And if I say 1 minus 2, which is negative 1, but we can just put 1 minus 2. And then we get 64. Okay, so this is a very similar trend. It is what we had initially. Okay, so we know that r in this case is a quarter. Okay, cool, we made sure. Now, how do we calculate the number of terms? Well, basically, the number of terms, you take your last term, which is 8. Okay, and you subtract your initial term, which is 0. And then you're going to add 1. Why is it that, let me just count with you, because at least we have until 8. It'll be 0, 1, 2, 3, 4, 5, 6, 7, 8. So you see we have 9. 9 terms. Okay, so that's why you have to add 1 to it all the time. All right, so we have R, we have N, we have A. Oh, by the way, this is A. Okay, Now we can use our formula and we can work out the sum of these 9 terms. Okay, our A is 1024. Our R is a quarter. We have 9 terms and this is minus 1. Okay, and that will be all over a quarter minus 1. Obviously, we will plug that into the calculator. 1024, and then we have a quarter, and to the power 9. I would have put that quarter in brackets actually, but I will trust that the calculator will do the things. And then we have a quarter minus 1. Minus 1. Okay, whatever that answer is, we'll just believe it. So it's 87,381 all over 64. We can then round off to 2 decimal places, and that is 1365. Remember, we are adding the values, okay? So we are expecting a big number, somewhat. Okay, 33. If we were determining the 9th term, that would be different because your answer should be small because our trend is reducing, okay? But we're getting the sum of the 9 terms. Okay, so that is 3.1.2. Just gonna take a little break and blow my nose. Okay, I'm back. So 3.2. The first 2 terms of a geometric sequence are that. So we have negative t squared minus 6t minus 9, and then our second term is t cubed plus 9t squared plus 27t plus 27 all over 2. So it says determine the values of t for which the sequence will converge. If we were looking at converging sequences, remember you start off with a very big number and then you are getting to a small number. You're converging. Okay, so where is that conversion taking place? Well, where there is infinity. Okay, and what are the conditions? If you know, for the conditions for r in this case or for infinity, we know that r should be in between -1 and 1. Basically, r should be like a fraction. Okay, it can't be 1, nor can it be -1, or else it's really not converging. So now we need to get r. And we know that r is basically t2 over t1. And we're going to have to do some algebra. Okay, so let's start with t1. Okay, I'm just going to copy it over. And yeah, let's get what t1 is. Let's try to simplify t1. Okay, so like I said, I do not like working with if there's a negative in front of t squared. I'd rather take it out. So then I have t squared plus 6t plus 9. Okay, and here I can actually tell that I can use factors here. Factors of 9 is 1 and 9. 1 and 9 won't give me 6, but 3 and 3 will give me 6. So I know that I have t, 3, 3. And because I have a positive here, it will definitely be that. So my final answer would be negative t plus 3 squared. Now we need to get t2. Okay, so I want to first work, because I have a cubic function. You can watch a video that we did, my husband and I, where we solve a cubic function either by long division or by synthetic. Synthetically. I definitely prefer the synthetic because it saves time. Alright, so with the synthetic formula, I'm gonna do it in red. It's fine. So you're gonna take the factors or not the factors, but the coefficient of t cubed, which is 1, coefficient of t squared, that's 9, coefficient of t, that's 27, and the last term is 27. And we need at least one factor there. Okay, so what I'm going to do, I'm going to check on the calculator. It is a very, I don't want to say laborious, but yeah, quite repetitive. Okay, I forgot what the term is there. It's quite repetitive, right? You need to start guessing maybe from -1 to 1, and if that doesn't work, we're going to put 2 or 3 or whatever. Okay, but, oh, the sun is out. But because we want to save some bit of time, I am going to assume, okay, that one of the factors is either 3 or -3. Okay, because if I plug 1 in there, okay, if I plug 1 in there, I'm going to get 1 cubed, which is 1, plus 9, plus 27, plus 27. I am not going to get 0 there if I plug all of that. Our aim is to get 0 at the end of the day. So 1 doesn't work. I don't think -1 will work either. Okay, so I'm just going to go to 3 and see if I have 3 cubed as one of the factors, and I add 9 times 3 squared, and I have 27 times 3. Okay, already this is a big number, so it can't be 3. So let me try -3. Okay, I think it doesn't want to move. Okay, let me start again. So I have -3 cubed. Okay, and then I have plus 9 -3 squared. Okay, plus 27 -3, and then plus 27. Okay, this is also not working out. Okay, so -3 cubed. Okay, so my, 27. Oh gosh, yay. Okay, so -3 does work. So basically what I'm saying is one of the factors is t is equal to -3. Okay, one of the solutions. Alright, so I'm gonna then put -3 over there. So how do I use the synthetic formula? Basically, I'm gonna drop down the first term, so that's 1, and I'm gonna say -3 times 1, that is -3. Okay, and then I add, right, the two terms. So yeah, I keep adding. So 9 plus -3, that will be 6. So then I take 6 times -3, that is -18. Okay, 27 plus -18, that will give me 9. Okay, 9, 18, 27. So I will have a 9 over there, positive 9. Then I say -3 times 9, that will be -27. And at the end here, guys, you must always get 0. If you don't get 0 here, there's a problem. So 27 minus 27, that is 0. So at least now I have my first factor. I know, I'm not using x. Okay, if t is -3, then t plus 3 is 0. Okay, so I know my first block, I have t plus 3. And then I have t squared, okay, plus 6t plus 9. Okay, so we are getting somewhere. I hope you're not lost in what we're doing. You're like, what are you doing? How's that gonna help us get t? Well, stick around. Okay, so here we have a positive. Okay, so now I have t cubed. Okay, so now I know I have t plus 3 cubed. Now let's get back to the question. My first term is -t plus 3 squared. Okay, remember we're trying to get r. This is what we're doing here. We're trying to get r. And to get r, we're going to say t2 divided by t1. And what is t2? T2 is t plus 3 cubed. Let's go check. Remember we had a half over here. Okay, I'm just going to say multiply by a half. and t1 is negative t plus 3 squared. Okay, so what is r? Well, I'm gonna take away this. I'm left with 1, so this is all out. Okay, so I'm left with t plus 3 times a half all over negative 1. So at the end of the day, r is a half t plus 3. Negative a half t plus 3. We have r, and we have our condition that r has to be in between minus 1 and 1. So I have negative a half t plus 3, 1, negative 1. So what I'm going to start with, I'm going to start by getting rid of the half. Okay, so I'm going to divide by half throughout, which is the same as multiplying by 2. Okay, negative 2 in this case, because I also want to get rid of the negative. Okay, yes. So if I multiply by negative 2, I will get positive 2. I will have t plus 3. And then I will have negative 2. So as soon as I divide by a negative or multiply by a negative, the inequality signs have to change. Okay, so they have changed. And now I have t plus 3. I need to get rid of that 3, so I'm going to subtract 3 on both sides. So 2 minus 3, that will be minus 1. I'm left with t. And then minus 2 minus 3, that is minus 5. Okay. I like it when the inequality signs are facing the right. So I'm going to change it around and put the smallest value. So minus 5, t minus 1. Okay, and that is the answer. Determine the values. So it wasn't just only one value of t, there were many. So they go from, because it's not really minus. Hello everyone and welcome back to MV Tutors. You're still with me and we are now looking at question 4. Please don't forget to like our videos as well as subscribe to our channel, and please do tell a friend, a classmate, anyone who's doing matric or upgrading, tell them about this channel so that they can practice and see whether they're ready and practice some more if they're not. Okay, don't keep this info to yourself. Alright, question 4. We have a graph. I hope you can recognize that it is an exponential graph. As soon as the x is an exponent, it is an exponential graph. Alright, and it passes through the point E. Okay, one thing you should recognize, it is a third to the power x. Alright, so it's positive. If you look at the value of a, it is positive, but less than 1. So your graph should be looking something like that. Okay, if you were to sketch it. Yeah, something like that. If it were positive, if a were positive and bigger than 1, it would do something like that. Okay, just so that you have an idea as well of the kind of graph you are working with. If you want to, as you're practicing and you don't know really how graphs look and if you plot them what happens, you can visit this web page. It's called Desmos. I will illustrate to you later on, hopefully, just to show you how to put in the graph and see how it looks and the changes that the graph goes through. Okay, but yes, so 4.1, it says calculate the value of a. Alright, so I'm just going to put, instead of g of x, I'm just going to say y is equal to a, and we have a third to the power x plus 7, and it passes through a point E. So if you want to determine the value of a, I will substitute that point, the x value into x and the y value into y. So the y value in this case is 10. Okay, the x value is negative 2 and then plus 7. Okay, so let us take 7 to the other side. Then we have 3. And then you have a, how should I do this? So this is a, 1 over 3 is the same as 3 to the power negative 1, and that is multiplied by negative 2. So I have 3, negative 1 times negative 2, that is just positive 2. So basically a is 3 over 3 squared, which is like 3 over 9, which is just a third. Okay, you know, we just take away 1, 3. So yes, we have a third, and that is A. Okay, now it says in 4.2, all right, that we have, or rather calculate the coordinates of the y-intercept. So again, if you're looking for the y-intercept, you will make x equal to 0. Okay, so the y-intercept, we have y is equal to a third, and then you have another third to the power x, which is 0. Or let's rather, yeah, we can make it 0 now, and then plus 7. Okay, so anything to the power 0 will basically be 1. So I have a third plus 7. Okay, so the answer is basically 7 and a third, or you could say 7 times 3, that's 21 plus 1, 22 over 3. That could be your answer. Okay, I will show you a little bit later on how to use the Desmos function. Okay, and then 4.3, you have h of x, and that is equal to a third to the power x. And now they're saying, describe the translation from g to h. So what was g? Okay, let's just write g again. So g is equal to a third times a third to the x plus 7. Okay, and then h is a third. Okay, so if you plot h, I'll do that let me just, like I showed you previously, so h will pretty much be something like that. It passes through 1. Okay, g on the other hand is, if you take this alone, g already moved 7 units up. It's like h moving 7 units up. Okay, so it would pass at 8. Okay, with the asymptote being 7. Okay, all right. But then what does this third do? Okay, well, you would technically just say 8 times a third, then you'd see what the third does. But how would you describe it in words? So I would rewrite g like this. I would say a third, and do you see that it's actually x plus 1 plus 7. So whenever you have x plus or x minus, you have a horizontal shift. 7 is the vertical shift, but anything next to x, plus x, minus x, or rather x plus something or x minus something, it's either a left or a right shift. So if it's plus 1, it has shifted 1 unit to the left. If it was negative 1, it would have shifted 1 unit to the right. So your graph then, if there you have 0 and 8, it would then be minus 1 and 8, so it would shift something like that. Oof, I know it's untidy, everything is everywhere, but yeah, that's what I wanted to demonstrate through Desmos. Okay, so that is pretty much what G is. But what is the question? They didn't ask us how do we go from H to G. They asked us how you go from G to H. So how would you go? I would firstly, if originally I was here and I moved 7 units up, okay, if I want to go back to where I used to be, I would shift 7 units vertically down, or just 7 units down. Obviously vertically means it's down. So shift 7 units down, or negative 7 units vertically. Okay, so that's the first thing if you want to go from G to H. Another thing, if you want to go from G to H, remember it was shifted to the left. From H to G, it was shifted to the left, right? So if I'm going from G to H, I need to shift to the right. Shift 1 unit to the right. Okay, I hope that makes sense. Let's answer the last question, then I'll show you this Desmos I keep talking about. So 4.3.2, it says determine the equation of the inverse of h. Okay, that's not bad. So h is like y is equal to a third x. And remember, if you're getting an inverse, you're just swapping the x and y. So I have a third to the power y. But we obviously want to write things in the form of y equals 2. So we're going to use logs. So I'm going to put a log in front of x. And I'm going to put a log in front of this one. I know for some people you're like, this is so easy. I can do it in one step. I know. But for some who don't know, this is just a reminder of how you do it. Okay, so if I have log x and I have a power, so a log, takes the power down, I have log a third. So if I want y alone, it would be log x over log a third. And finally, I would say the inverse of h minus 1 is equal to log, so this one is at the base, so it will be at the base, and this one is just up there. So yeah, so the inverse of h in the form of y, okay, they want it in the form of y. So let me just say y is equal to log base a third x. And that is it with question 4. If you guys not interested in the Desmos thing, we can move on. For those who are interested, you can just keep watching. Okay, so you would, in your Internet Explorer, whichever one you use, whether Chrome, whatever, just Google Desmos, alright? Then you can put in your function. So let's say we want y is equal to a third of x, or if you really want to put g of x, you are welcome. How do I delete? Okay, it's fine. Y is equal to a third x. So 1 divided by 3. This is how you delete. Okay, to the power x. Alright, and you see how it draws it out? You can zoom in if you want to, and you can see that your y-intercept is equal to 1, right? If you wanted to draw the other side where I told you can have y is equal to 3 to the power x, that's how it looks, okay? And you can definitely shift it up or down. Let's say minus 5, and it goes all the way down. Obviously, it started having an intercept, y-intercept of 1. Shifting 4 units down, it's going to have a y-intercept of 4. And your equation of the asymptote will be y is equal to negative 5. So you can do whatever you want to these graphs. So in our case, we had a third, right? And then it shifted 7 units up. Okay, let me just switch this one off. And this is how our function looks. Okay, so our y-intercept, remember when it shifted 7 units up, without the third being put in front, so it was just the third x plus 7, your y-intercept was directly on 7. No. It was 1 initially, 7 units up, it became 8. But now, because you have to factor in this third, your y-intercept is going to be 8 times a third, which is 7,3333. Okay, so yeah, that's basically that. You can use it to draw any function, guys. You can have y is equal, or rather you could say g of x if you really want to. So g, now how do I go back? Snap. Yes, there you are. So yeah, if you have g of x, okay, is equal to, what equation do you want to draw? Let's do a parabola. So you have 2 and then x minus 2. Let's shift it to the left 2 units, and then we bring it 2 units up. Okay, and this is, squared. I forgot to put in the squared. Now I have a straight line. So this is how your function would look. It shifted 2 units up and 2 units to the right. Ooh, did I say left? Minus 2 means 2 units to the right. So that's basically how you use the Desmos function. And go pee. use the use the Desmos function, especially if you don't know how the graphs are going to look and you want to practice and you want to understand functions even better. I know functions is a topic where a lot of students struggle, but you really don't have to. Just use this graphing calculator to help you see what happens to the graph if you shift it right, minus, shift it to the left, plus, shift it up, down, expanded, contracted. Like if I remove the 2, it's going to be more flatter. Okay, if I put a half, it will be even more flat. Okay, so stuff like that that helps you by flat, not flat, I mean wider. Okay, the smaller your number gets, the wider your function becomes. The bigger your number gets, the coefficient of x squared, the narrower it becomes. Okay, so these are things that you can actually see as you use this Desmos functionality. All right, bye. Hello everyone and welcome back to MV Tutors. I'm still with you guys doing question 5. Again, you can use the Desmos graphing calculator to help you understand functions more. Your exponential, parabolic, hyperbolic functions, all of them. Even your trigonometric functions, you can use that graphing calculator to see visually what happens when you shift things, invert things, rotate them, reflect them, everything like that. Okay, so now question 5. Again, please don't forget to tell your friends about this channel, and Luena, you must like and subscribe. Okay, so we have here a hyperbolic function, okay, g of x. Now the following information about this function is given. So if you have a hyperbolic function, guys, if a is positive, it will be in these quadrants. If a is negative, it'll be in these quadrants. Okay, now they tell us that the domain is basically x is an element of R, meaning it goes from negative infinity to positive infinity, except where x is equal to -2. So we know for starters that, okay, one of our asymptotes, so yeah, it could either be this function or that function, but we know that one of our asymptotes is x is equal to -2. Okay, and then it says the x-intercept at k, okay, is 1 and 0. So we have an x-intercept of 1. Okay, so this is k. And then we have a y-intercept at n, negative a half. So we have negative a half over there. And that is n. Okay, so I have limited space. So we know that one of our pieces of the hyperbolic function, I don't want to say piece, but a portion of the hyperbolic function does this. Okay, it can't be like that, guys. It just can't. So it has to be like that. Okay, so then what do we know about a? A cannot be bigger than 0. A has to be negative. Okay, so therefore our function, we don't have this scenario over here. It has to be this. I actually forgot why I drew it twice. I wanted to show that we can't have this, basically, like it just can't work out. Like, this piece over here doesn't work out. So a is smaller than 1. So this is the function that we have. But what we don't know is, do we actually have a horizontal asymptote? Okay, we don't know about that, but at least we know the shape of the graph and we know that a is less than 0. Now, what do they want us to calculate? Show that the equation of g is given by that. Okay, so with the information that we have, I'm going to start with the x-intercept, where y is equal to 0. Then I'll move over, maybe let me not put a border yet. I'll move over to the y-intercept, where x is equal to 0. So if I take my graph there, x-intercept, I know that y is 0. And then I have a, x plus p, okay. The p, because I know that it shifted to the left, okay, I'm gonna have negative 2 plus 2, sorry, because it shifted to the left, so x plus 2. All right, and then plus q. I don't know about its vertical shift, but I know with the vertical asymptote, p is negative 2, okay. Yes, x is negative 2, hence, yeah, if it shifts to the left, it has to be plus. All right, so I have that. So yeah, y is equal to 0. What can I put there? What else do I know? So the x-intercept, they gave it to us as 1 and 0. Okay, I forgot to put 1 where x is. So 1 plus 2. Okay, plus q. So I can take 1 plus 2, which is 3, to the other side, or just multiply by 3 throughout. So I'll still have 0, and then I'll have a, and I have 3q. So that is my first equation. Okay. Then if I look at the y-intercept, I know that x is 0. So I have y. Oh, let me just put in what the y value is. Y is negative a half. Okay. I still have a. Then I have 0 where x is, plus 2 plus q. So I'm going to multiply by 2 throughout. So I'm going to get negative 1 is equal to a plus q. And that is my second equation. Actually, I'm going to go ahead and say a is equal to negative 3q and just make that my first equation. Okay, then I have my second equation over there. So I'm just going to substitute the first equation into the second. Okay, so 1 into 2. So with my second equation, I have negative 1 is equal to negative 3q, which is the value of a, plus q. So negative 1 is equal to negative 2q. Ne? Yes. So negative 3q plus q, that is negative. Something doesn't look right. Sure, guys, I forgot to multiply ASCIIs. I'm sorry, guys. I forgot to multiply by 2 there. Okay. Okay, so if I multiply by 2 throughout, I will have a plus 2q. So even here, I need to have plus 2q. Okay, because I can see if I if I get q with what I had previously, I will not get 1. So that's a problem, which is, it's quite nice if they give you something to work towards. Okay, we already have the x plus 2, but we need to get the 1 for q. So I have negative 1, and then negative 3q plus 2, that's negative q. So I can see, okay, q is 1. I'm happy again, so I got 1. Now I need to get a. And I know that I need to substitute the value of q into my first equation, okay, so that I can get what a is. A is negative 3 times q. Q is 1, so then a will become negative 3. So I'm a happy learner. I can get my final gx equation. So that will be negative 3 because I have a as negative 3. And then x plus 2 because it did shift, the asymptote did shift 2 units to the left. And then plus 1. Okay, so that is my equation. And therefore I know that my horizontal asymptote there is actually 1. Okay, that is my graph. They didn't ask us to draw it. I'm a very visual learner, so it makes sense when I draw things. I can see it and I can believe it. I'm a Thomas. Okay, so write down the range of G. Okay. Yeah, so if I look at my graph, so it basically starts at negative infinity, right? Until it reaches the horizontal asymptote there, we actually have y is equal to 1, and then it goes again from 1 to positive infinity. So there are two ways in which you can write down the range. You could say y is an element of negative infinity. We never put square brackets around infinity because we don't know what the value is, and because y equal to 1 is our horizontal asymptote, you cannot put square brackets around that too. So it goes from negative infinity to 1, and again from 1 to positive infinity. Another way you could write it, you could say y is an element of R, okay, because it has all the values, but also y cannot be 1, okay. So that's how you would write it. That is the range of G. Then 5.3, determine the equation of H, the axis of symmetry of G, in the form y is equal to mx plus c, where m is equal, or m is bigger than 0. Okay, let me just redraw this graph again. Okay, so we know our vertical asymptote there is at 2, our horizontal is at 1. My graph is definitely not to scale. We have our x and y intercept. Okay, and we have our other form of the graph. Now, whenever we're looking at the equations of the axis of symmetry, please don't forget this is what they're referring to. They are referring to these equations. Okay, let me just shift it a bit. Yeah, they are referring to these equations, okay, where with 1, because you have a negative gradient over there, okay, it'll be y is equal to mx plus c, and this m, with these equations of the axis of symmetry, the gradient is always 1, okay, but if it's going down your line of symmetry, then it will be negative 1. Your gradient will be negative 1. So in this case, you have y is equal to negative x, but we don't know what the c value is. Whereas here, when it's going, from left to right, it's going up, our gradient will be positive 1. So it will be y is equal to x plus c. Just say c1 and c2. Okay, but in our case, we actually have information. We know the gradient because that's what you need if you want to get an equation of a straight line. You need a gradient and you also need a point. We have a point on this function. The point is the intersection of the asymptotes. Your asymptote, remember we had y is equal to 1 and here we had x is equal to negative 2. So we know that the point of intersection is negative 2 and 1. Okay, so we are happy because we can now determine what the equation is. Okay, our gradient, like I said, it is positive 1 because they told us m has to be bigger than 0. Okay, and then our point is negative 2 and 1. Okay, so now we can plug all of these in the equation. Y is equal to mx plus c. Y is 1, m is 1, x is negative 2, and we are looking for c. So c is 1 times negative 2 is negative 2. Take it to the other side, it will be plus 2. So we can see that c is 3. Therefore, our final equation, it will be x plus 3. Okay. If you want to, if you have time, you could actually determine the other equation, but that was not asked. So it means that, yeah, the y-intercept is 3. Didn't really have to put that. I just, put that for information sake. Okay, so we have our equation. And then the last question, 5.4. Write down the coordinates of k prime, the image of k reflected over h. Okay, let's go back to our... Okay, this is our point here, k. Okay, its reflection, because it's reflected over this line, y is equal to x plus 3. Okay, I hope you can see it. This is the line of reflection over here. that we just worked out previously. We don't just work things out for working out's sake. We're probably going to use it some way. So k prime will be somewhere here. Okay, so this is smaller than -2. So whatever x value we get, it should be smaller than -2. And whatever y value we get should be above 3. Okay, close to 3. So how do we get it? Well, I know that k originally is 1 and 0. So for it to get to k prime, what needs to happen? Okay, I will use this equation, y is equal to x plus 3. Okay, because that is my axis of symmetry. So that is what I'm going to use. So in this case, y is equal to x plus 3. Okay, so if I want to get my y value, okay, for k prime, I would say x. So what is x? X is 1. Okay, we take 1 and we add 3. Okay, so my y value is 4. So I have 4. And then if I take this equation, y is equal to x plus 3, and rewrite it in terms of x, okay, meaning x is equal to y minus 3, for me to get my x coordinate, I would take y. So what is y here? Y is 0. 0 minus 3. Therefore, I have minus 3. So this is my answer. And looking at minus 3 is smaller than minus 2. So yeah, that makes sense. And 4 is close to 3, just 1 unit above. But I'm confident in my answer, and this is what it is. And we are done with 5.4 and the rest of 5. Actually, I just remembered they said this is h. I'm reading like, what is h now? So basically h of x is equal to x plus 3. Should write it like that because they asked for h, the equation of h. So yeah, but basically we're done with question 5. See you later at question 6. Hello everyone and welcome back. You're still with me for question 6. And yeah, we have a parabolic function there. Let's see what's happening and what we can do. So the sketch below shows the graph of f of x. We have c as the y-intercept, a and b as the x-intercepts, and d as a point on the graph. Now, what does 6.1 want from us? Calculate the coordinates of E, the turning point of f. There are 3 ways I would calculate the turning point, but the one way is dependent on getting the x-intercepts. So yeah, but you can get them. So once you get the x-intercepts, a and b, you work out the distance between a and b, and then you go halfway, and that will give you your x value. And once you get your x value, you substitute it in the equation to get your y value. Okay, that's the first way. The second way, I would use calculus, meaning differentiating, because on the curve at the turning point, that is where your gradient is 0. So I would get the first derivative, make it equal to 0, get the x value, take that x value, substitute it in the original equation. The third way, I would use the function of x. The x coordinate of the turning point is equal to minus b over 2a. There are actually 4 ways. The fourth way, I would complete the square such that my equation is in the form where I have p and q as my turning points, and I can put them in. So there are 4 ways of doing it. I am going to take the form of differentiating. Okay, so yeah, if I were to differentiate the f function, basically I would multiply by -2 times x, and then I'll have -6. Okay, make that equal to 0. I'm basically taking the root that is quick. Okay, that's what you do when you get to an exam. You don't take the longest route unless if it's the only route that you know. Okay, so I'm going to divide by -2. Then I have x is equal to -3. Does that make sense? Yes, e is on the negative side of x. What do I do then? I take this -3, I plug it into the original equation. Okay, then I get my y value. So, and then minus 6, minus 3, plus 7. Because we don't like wasting time, we are just going to plug it in the calculator as it is. Okay, minus 6 plus 7. And then our answer is 16. Does that make a little bit of sense? Yeah, well, it can be 16. So then our coordinates of E, the turning point, is minus 3 and 16. Now, 6.2. Write down the value of K. Okay, so basically we have the X value of D. Now we're looking for the Y value. So what are we going to do? We're basically going to go to our original equation and substitute in minus 5. Okay, so minus 5 squared. Okay, and then 6 minus 5 plus 7. Alright, we're going to go back to our calculator and we're going to put minus 5 where minus 3 was. Okay, so now we have 12. So the coordinates of D are minus 5 and 12, but they ask for K, so K is actually equal to 12, and that makes sense. If E was 16, then D has to be like less, which is 12. So I'm good with that. And then now 6.3. Determine the equation of the straight line passing through C and D. So basically what they're looking for is, okay, my PDF doesn't want to be edited. It's all good. But yeah, we want to draw a line between C and D. Okay, so this is my parabola. I have D over there, which is minus 5 and 12. Okay, and I have C, which is the y-intercept. Okay, I know that the x value is 0 and the y value should be 7. Okay, so I want, what do they want? The equation of the straight line. Okay, so something like that. Okay, that equation, that line, I mean. Okay, so what do we need to get an equation of a straight line? Basically, we need, first and foremost, the gradient, and we need any point. Okay, so we already have 2 points, so that doesn't really matter which one you use. I would go for the y-intercept because at least one of them is 0. But if I need the gradient, I have to use both points. So I'm going to take the y value of C. Okay, so y is C minus yd over xc minus xd. So the y value of C is 7 and the y value of D is 12. Okay, the x value of C is 0 and the x value is minus 5. So 7 minus 12, that is minus 5, and then 0. Yes, our gradient should be negative. So I have positive 5 there, so my gradient is negative 1 because from D to C it is going down. So I have a point and I have a gradient. Okay, now we can substitute it here to get what the C value is. So I'm going to use C as my point, which is 0 and 7. Okay, so I'm going to substitute 7 in there. The gradient is minus 1. X is 0 plus C. So, yeah, C has to be equal to 7 because it passes there. Alright, so my final equation is minus x plus 7. And that is that line y is equal to y is equal to minus x plus 7, and that is the answer right there. Okay, so that was 6.3, and now we go to 6.4. Okay, a tangent parallel to CD touches F at point P. Okay, it is parallel. Okay, determine the coordinates of P. If it is parallel to CD, Okay, so basically copy and paste it somewhere there. So this function is tangent, ne? Tangent to f, it touches f, and it is parallel to CD. So P is somewhere there. Okay, and I know that the gradient of P, because it's parallel to CD, is equal. Okay, both, yeah, because they're parallel, the gradients are equal, so it's also going to be -1. But they're not asking for the equation of the line that is tangent. They're basically asking for the coordinates of P. Okay, so how are we going to get the coordinates of P? So what I will do, I will use again calculus to get the coordinates of P. Why? Because on a curved graph or function or whatever, your gradient, okay, your gradient is always like one point. So you'd have a gradient over there, gradient over there, gradient over there, because it's tangent, and we know that at the turning point the gradient is 0. So here at P, we know what the gradient is. The gradient is -1, okay, because that's why they told us that the lines are parallel. So I know if I differentiate my function, okay, I will not make it equal to 0, just like we put at a turning point. Gradient there is not 0. I would make it equal to the gradient, right? And what is the gradient? The gradient is -1, okay? So again, I'm going to differentiate. We already differentiated before, so we can just say yes, it's -2x minus 6, but instead of 0, we say equal to -1, okay? And then we solve for x, and then that's the x coordinate of P. After that, we take the x value, substitute it back to the original equation, and we get the value of the y value of P, okay? So -2x, if I take -6 to the other side, it's +6. So 6 minus 1, that would be 5. And then x is -5/2. And that makes sense, okay? This P function is actually, it's to the right of E. Okay, what was E? -3. So it makes sense that it's 2,5. Alright, and then we're going to take -2,5, substitute it back into the equation. So -2.5 is equal, okay, -6, -2.5, plus 7. And then we take our calculator. At least we still have that -5. So I'm going to say -5/2. That's the nice thing about not deleting things on your calculator. So 15,75. So 15,7, was it negative? No, positive. 15,75. It's the same as 15, 3 1/4. 15 times 4, that's 60 plus 3, same as 63/4. It doesn't matter how you write it. But yeah, so let me check before I tell you lies. Okay, so the coordinates of P, which is what they were asking, that would be -2.5 or -5/2 and 63/4. Okay, and that's it. We're almost done with question 6. And then 6.5, for which value of x will f of x minus 12 be bigger than 0? So basically, if you shift this graph 12 units down, which values of x, will this graph be valid? Okay, I hope that makes sense. Okay, but I actually don't want to shift the graph 12 units down. What I would do rather, f of x minus 12, I would rather take the 12 that side and say, where is f of x? So the y values of the function f, where are they bigger than 12? Okay, if I look here, remember d was 12, right? So if I look at it graphically, 12 is somewhere here. Okay, so basically the y values would be here. Okay, so these values are bigger than 12. Okay, so I want to know then, what are these x values? So I know one of them is -5, but what is the other one? This is basically what they're asking. If you decided to take the graph 12 units down, your turning point would be 16 minus 12. It would be at 4. I don't want to deal with that, but graphically you could show it and you would get it. Okay, if you don't really understand what's going on still, what you can do then is just write out the equation of f of x and make it bigger than 12 and then solve, or leave it as it was before. Okay, and then you can basically solve. What did I do now? Cool. So basically f of x, just say minus x squared minus 6x plus 7 minus 12, and then you just make it bigger than 0. You can just solve from there. You don't have to go and, complicate your life. But I feel like the easiest way is to look at this to say the one value is -5, and if I take this line y is equal to 12, y is equal to 12, and I substitute it into the equation, I will get what the other x value is. But yeah, let's go and solve it. Okay, so I have negative x squared minus 6x, and then 7 minus 12, that is -5, bigger than 0. I don't like using negatives, so I'm going to say x squared, I'm dividing by the negative. So x squared plus 6x plus 5, and because we are dividing by a negative, this has to turn around. Okay, and that will be smaller than 0. Alright, so at the end of the day, I have x, I'm taking the factors, okay? So plus 5 plus 1 smaller than 0. So basically then, the value of x would be smaller. Okay, going back to my sketch. Remember I said one of the x values is -5, and the other x value would then be what I solved now, which is -1. So if I were to sketch my graph, okay, and I were to look at x, that would be -5, the other one would be -1. Okay, so if I solve for x, I would say x is equal to -5 and x is equal to -1. But now they said determine the values of x. Okay, so basically I then have, because they are smaller than 0, I am looking here. Okay, yeah, so basically x is bigger than -5, x is smaller than -1. Okay, so maybe I shouldn't say they're equal to, they're just smaller. So basically x is in between -5 and also -1, and we can leave it there. Okay, and that is the end of question 6. I'll see you again at question 7. Hello again, and so we are at it with question 7. Please don't forget to like our videos as well as subscribe to our channel and spread the word to your classmates, those that you know that are upgrading, writing in November. And yeah, this is quality stuff we're giving you, so don't keep it to yourself. Alright, question 7. It says 7.1, how many years will it take for an investment to double in value if it earns interest at a rate of 8.5% per annum compounded quarterly? So initially you had a certain value, and then over time it doubled. Okay, and then now we want to know how long did it double, because on face value you're like, oh my gosh, it doubled. You're probably thinking it doubled in a month, but how long did it double? How long did it take? That's what we're asking. And then the interest rate is 8.5% per annum compounded quarterly. Okay, so let's see, they ask for the amount of years, right? So we're gonna, because we're dealing with lump sum values, we're using the normal compound formula that we know. Okay, if it was regular payments or payments of the same value made over, a certain time, maybe per month, per quarter, then we would use the annuity equations. But yeah, so it resulted as being double. This was the initial 1 plus I, so 8.5% per annum compounded quarterly. And then the N, it's in years, right? So normally if they said it is 4 years, then what do? You would say 4 times 4 because it's quarterly. So here I would put 4 in, okay? So yeah. And now we can solve. Alright, so we're gonna have 2x divided by x. And then in this bracket, let's see if the calculator will give nice values. If it doesn't, then yeah, we'll just stick to that. So where is the percentage? Oh, shift percentage over 4. Okay, I think we can write down this value. 1,02125. And all of that is to the power n. 4n rather. So what we're gonna do, we're gonna definitely use logs. Okay, so here I'm gonna remove the excess, so I have log 2 is equal to 4n log 1,02125. So 4n is equal to log, my base will be the 1,02125 and 2. Okay, and n will be all of that divided by 4. I'm not gonna write that again. Okay, so logs, where are the logs on this calculator? Okay, so we have log 1,02125, and then we have 2 over there, and then we're dividing it by 4, so we get 8,24, and that is the amount of years, 8,24 years. Okay, and that is it. So we can move over to 7.2. Now it says a company purchased a machinery for 500,000. After 5 years, the machinery was sold for 180,000 and new machinery was bought. Okay, so that makes sense. When you start working, you're going to probably buy a car. If the car is valued at 200, the moment you drive out of the store, best believe it's going to be probably equivalent to 170,000 just by it leaving the store. So obviously over time it will depreciate. So yeah, it makes sense. I mean, when we bought our car, it was 205,000, and after 6 years it's only worth 105 or something along those lines. So machinery, cars and all of that, they depreciate quite a lot, unlike property, which appreciates over time. So invest wisely when you start working. Hint, hint. Now it says calculate the rate of depreciation of the old machinery over the 5 years using the reducing balance method. Okay, so this is the reducing balance method. Okay, instead of a plus, you have a minus. So initially it was 500k and then it was sold for 180. So later on it became 180,000. Initially it was 500,000. And then 1 minus I, this is what we're looking for, and it was done over 5 years. Okay, so we can solve for I. So I'm just gonna say 180 divided by 500,000. Okay, and then it'll be 1 minus I to the power 5. So I'm going to get rid of that power 5 by doing this. Okay, so let's see what that value is. I wanted to do some more, but let's just yeah, let's just do what we can with what we have. So we have 5 over there, and then 180,000 over 500,000. So we get 0,815. I'm just going to say 0,815. I have 1 minus I. So if I take I that side, and I take that 0,815. So now I am getting 1 minus the answer, which is 0,1850. Oh no, 0,1848. Okay, but we normally write this in percentage, so you're gonna multiply by 100, and then you get 18,48%. Okay, this was doable. Now 7.2.2, it says calculate, or rather the rate of inflation for the cost of the new machinery is 6.3% per annum over the 5 years. So basically, if I didn't buy that car and left it at the store and it was valued at 205k, over 5 years, after 5 years rather, it would be more than that. Okay, so this is what we want to determine. If that machine, okay, so a new machine after 5 years, it wouldn't cost 500,000, but it would be more than 500,000. So we need to get what that cost is. Okay, still using the same formula. Okay, but this time obviously we're gonna use the interest rate, that is inflation. Okay, so we're gonna use that 500,000 and say 1 plus 6.3% per annum. Okay, it's just per annum. And then it's 5 years. Okay, so we can just plug that into the calculator. 500, 500,000. 1 plus 6.3% to the power 5. So now it is worth 635,011 cents. So 678,635,11. Okay, it didn't say anything about rounding it off to the nearest rand. No. And now the last question, for question 7. It's the company set up a sinking fund. Okay, why would they set up a sinking fund? Well, basically, if I'm buying a car today and I know after 5 years it will be less, and I want to upgrade to another car, a family car, maybe before 5 years I was just a bachelorette, and after 5 years I'm a mommy, I want to get a bigger car. So if it was valued 500 rand today, 500,000 today, and over 5 years it's now what, 180,000, I can only sell it for 180k, and the new car is what, 678. So that balance there I would have to start investing for. Okay, so that by the time 5 years comes, I can just buy the car cash and not have to take a loan from the bank. Okay, so this is what a sinking fund is for, right? You want to avoid having to use the bank. You want to save the money yourself so that you can buy the thing cash. So what do we now need? Let's read the rest of the question. It says the last payment was made 3 months before the new machinery was purchased at the end of 5 years. Okay. The interest earned on the sinking fund was 10.25% per annum. It's quite a reasonable interest rate. Compounded monthly. So the money from the sinking fund and the 180 from the sale of the old machinery was used to pay for the new machinery. So first of all, I would ask, okay, now it says calculate the monthly payment into the sinking fund. Firstly, I would ask myself, what do I need to save the money? What amount would I need to save? Okay, so, or rather, yes, what amount do I want to get at the end? Okay, so basically it would be the 678,635,11. This I'm calculating If I'm saving for the future, I'm going to use the future value equations. I'm calculating the future value amount. So it's 678,635,11. And I know that we're going to sell this machine for 180. So what amount do I need to save it for? Save for? I need to save for 498,000. 635,11. This is what I need to invest for. Okay, this is my future value. And then what am I looking for? I'm looking for the monthly payments. What is my interest rate? I was given an interest rate of 10.25% compounded monthly. The one thing I'm left with is the amount of time. So I know the temptation would be to take 5 years, but they said the last payment was made 3 months before the new machinery was purchased at the end of 5 years. So here's the thing. If I'm making an example, if I'm going to save money for a year, okay, if I draw a timeline for a year, so this is Jan, February, March, April, May, June, July, August, September, October, November, December. Ooh. Okay, and I say that my last payment is in January. Okay, so if I start paying the money, like I open the account and I start paying today, if I start paying today over a year, the time that I'm looking at, the months rather, that I'll be looking at, they will be 13 and not 12. Okay. There will be 13 months if I pay the day I open the account. Okay, so N would be 13. But if I start paying, let's say I open the account and they're like, oh, your first deduction will be, the following month. I opened the account today in Jan, but I'm going to start paying into the account the following month. So then I would start here and I would end there in January. Okay? Or they say I start making payments today, but my returns will be given to me in Jan. Then my time would be 12. Okay, I would have used 12 months. So just be careful. If you're starting to pay today and you're getting the money, if you're starting to pay today in Jan and you're getting the money next year Jan, then it'll be 13 months or 13 periods you need to consider. But if you are opening the account today and your money is coming out in Jan, not that you're making your last payment in Jan, you're not making your last payment in Jan, you're getting your money out in Jan, then it means it's over a 12-month period. I hope I made sense. I really hope. If I didn't, please just comment below and I'll try to explain again. So in this case, the company set up a sinking fund and made the first payment into this fund on the day the old machinery was bought. So they started on that day. So if it is over 5 years, guys, I'm going to have to take the 5 years times the 12 months and add the 1 because they did it on that day. And the last payment was made 3 months before the new machinery was bought at the end of 5 years. So if it wasn't made 3 months before, this would be N. But because it was made 3 months before, I have to then subtract the 3. I hope we are still together. So 5 times 12, that is 60, plus 1, that's 61, minus 3, that is 58. Okay, 58 months. Okay, so if you did not add that 1, you would have probably used 57, and that would be incorrect. Okay, so we have everything that we need. We just need the formula, and then we are good to go. So it's a future value because we are investing. We didn't take out a loan. So future value is X and then 1 plus I to the power N minus 1. All of that is divided by I. Okay, let's go back to the question. Question 7. So we know our future value amount was 498,635. So 498,635,11. We are looking for x. 1 plus 10,25 divided by 4. N is 58, 58. And then we're subtracting 1, and then all over 10,25% over 4. Okay. It's quite a heavy calculation, but so to get x, we are going to take that 498,635,11 and divide it by that lot. I'm not gonna rewrite it. Okay, so the reason why I want to do everything once is I don't want to lose, because I have comma 1 1, but there's 1 1 3 6 2 0 blah blah blah. I don't want to lose those decimals yet. Okay, so I would take that answer that I got previously, and then I'm gonna plug all of this in the calculator. So I have 1 plus 10,25%, and this is where you are hoping that the calculator does not crash on you. Okay, this is to the power 58, and then minus 1. I'm closing the bracket. No, I don't need to close it. And then we go to the denominator where we have 10,25%. Yeah, this is where you're likely to make errors, I'll be honest. Okay, so I have 1 plus 10,25%, 58 minus 1, and then 10,25 divided by 4. Okay, somewhere I made an error. Let me check. Okay, I'm seeing my error. I forgot, guys. This is supposed to be 12. This is compounded monthly. Why did I put 4? Alright. So I probably lost my values there. Okay, so this should be... I think I lost my stuff. This should be divided by 12. Yeah, I definitely lost my values. I can't use that answer anymore. So it's 678. Let me try to put it in manually. 678. No, 498. 498, 635, 11, 36, 20, 77, 15. Okay. This looks more like it. So x will eventually be 6,678.62 rands. Okay, that's how much this person needs to put in every month so that they can buy the machinery cash and not have to use the bank to do all of that. Okay, or the company rather. They need to put in this much per month for 58 months. Okay, and that is it. I think we are done with question 7. Thank you for bearing with me and for seeing my mistake. For those who didn't see it, I hope you learned something. Don't repeat my mistakes when you write. Thank you. Hello everyone and welcome back to MV Tutors. I'm still with you. We're about to do question 8. This should go by fairly quickly, 11 marks. And let us do it. Please don't forget to like our videos and subscribe to our channel. Tell a friend, a classmate, someone who's rewriting. Don't keep the information to yourself. And thank you for tuning in. So determine if, now I forgot, it's not prime x, but yes, that from first principles, given that f of x is minus x squared. Okay, so if f of x is equal to negative x squared, you can go to your formula sheet and you can see there what equation you need to use. Okay, we're going to use f prime x, yeah, I think it is prime, is equal to the limit of h tending to 0, and then we have fx plus h. This is where you really need to score your marks, because it's not a complicated function that they gave you there. So yeah, please collect as many marks as you can. So when you write the answer, please, you're always going to use the limit. Okay, it never leaves. The only time it leaves is if you don't have h any longer. So now x plus h, I'm literally going to take the negative and then I'm going to say x plus h and I'm going to square it. Okay, and then f of x, that's basically negative x squared. Alright, and that is all over h. Okay, so now we're going to multiply it out. So I have negative on the outside, I have x squared, x plus h times 2, that will be 2xh, and then h squared. Okay, and then I have plus x squared, and that is all over h. Again, we don't leave the limit out. So we're gonna just take out those brackets. I have negative x squared, negative 2xh, negative h squared, plus x squared over h, and then we're still keeping this limit. If at any point you leave it out, you lose marks. Okay, so I can scratch these ones out. Negative x squared plus x squared is 0. And then I have with me left is negative 2xh minus h squared over h. Then we take out the common factor because I want to get rid of this h in the denominator. I'm going to take out h. I'm left with negative 2x minus h all over h. Okay, then I'm left with minus 2x minus h. Now I can use this limit as h tends to 0, so I'm basically going to substitute 0 where h is, and my final answer is negative 2x, and that is where we end this 8.1, and we can go over to 8.2.1. So now we are getting f prime, given that f of x is 4x cubed minus 5x squared. This should go by quite simply. So if we've been doing this, we have been doing this in other questions. So basically I'm going to take the exponent and multiply by the coefficient of x, so that's going to be 12x. Then I subtract 1. Okay, so 3 minus x, that's 2. Then here, same thing, negative 5 times 2 is negative 10, and then 2 minus 1, that's 1, but we don't really put it there. And that's it. Now 8.2.2, that looks like a challenge and a half because we have fractions. It is quite loaded. So what are we going to do? We have negative 6, okay? And then x, if we have a square root, root 3, basically, it's the same as saying x to the power a third, okay? And then we have plus 2, and all of that is divided by x to the power 4, which can be written as x to the power negative 4. Okay, we want to put everything in a straight line. Okay, so now we're going to multiply in that x to the negative 4. So I have negative 6x a third minus 4. And then I have plus 2x minus 4. Okay, if I take a third, and you know what, this calculator is going to give me other answers. If I take a third and I subtract 4, okay, so a third, that's basically, it's like saying a third minus, 12 divided by 3, 4. So I have minus 11 over 3. Okay, so I'm still putting this dx because I haven't yet started differentiating. So I have minus 6x negative 11 over 3. Okay, and then I have plus 2x minus 4. Okay, now that I'm here, I can then start giving the answer. So the answer, I have negative 11 over 3 times negative 6. So I have negative 66 over 3. Ooh. That was scary. Okay, negative 66. Oh, actually it's a negative 11 over 3 times negative 6. So that will be positive 66 over 3. And I have negative 11 over 3 minus 1. Then here, negative 4 times 2, that's negative 8. And then x, negative 4 minus 1. So my final answer, 66 divided by 3, that will be 22. Then x, remember 1, so negative 11 over 3 minus 1, that's the same as 1 can be 3 over 3, right? So minus 3, minus 11 minus 3, that's minus 14 over 3. That's a power, I hope. That's an exponent. So it's minus 14 over 3. And then I have here minus 8x, minus 4 minus 1, that is minus 5. And that should be the final answer. And we are done with question 8. Welcome back, everyone. This is Tulu from Banana Ventures, and we are looking at question 9. So it looks like I'll be doing the whole memo with you guys for this paper. Okay, so question 9, we have a cubic function. So sketched below is the graph of f of x. Okay, we can see how it is going. The x, well, I know the value in front of, or rather the sign in front of x cubed is positive. And why is that? Because at the end of this cubic function we have a smiley face. So the coefficient of x cubed has to be positive. Alright, so the x-intercepts of f are at 3, positive 3, and m. So when we have a turning point, we know that we have 2 x values there. Alright, and m lies on the negative x-axis. K, which is the y-intercept, is 0 and negative 3, and then we have m and n, which are turning points of this function f. Now 9.1 says, show that the equation of f is given by that x cubed minus x squared minus 5x minus 3. Okay, so let's see what we have. This is question 9. Okay, this is 9.1. So we have an equation there, f of x, which is equal to x cubed plus ax squared plus bx plus c. And what information have they given us? Well, firstly, I'm going to rewrite this equation like this. Because we don't have, they didn't put a coefficient here, I'm just going to go ahead and just use 3 brackets. Okay, well, because 1 is a turning point, let's just use 2 brackets. Okay, so we have one x-intercept that we can put there. So I can say x minus x1, that's the equation I'll be using, and then x minus x2. Okay, and we have f of x. So if I substitute the x-intercept that we know, okay, what x-intercept do we know? We know that it is 3, right? So I'm going to have minus 3 over there. And in the second one, where m is, we don't know what that is. Okay, so that is our unknown. All right, and then we can plug in our y-intercept. They've given us it is -3, and we know where we have our y-intercept. X is 0. I'm just putting it all at once. Okay, if I'm confusing you, what you can do first is substitute the x-intercept and then later on substitute the y-intercept. I just thought, let me just do it once. All right, so then at the end of the day, I will have negative x squared, okay? But if I, negative x to the power 2. So if I apply the squared, I would have x squared, okay? And that is multiplied by -3. And I'm going to bring this 3 to the side, so it will be plus 3. So then I have -3x squared plus 3, okay, is equal to 0. So if I take out the common factor, as -3, I have x squared minus 1. Okay, so if I were to solve that, I have x squared minus 1. So that basically I can then say is x minus 1 and x plus 1. But in this case, okay, so then we can say x is equal to 1, difference of two squares, né? X is equal to 1 or x is equal to minus 1. So we know it cannot be equal to 1 because it can only be at 1, okay? Sorry, at -1, because that's where m is. They told us on the negative side. So x is equal to minus 1, but we're not done yet. They said we must look for the equation. All right, so since x is equal to 1 is not part of the solution, what do I have then? All right, so I have f of x, just take this up, is equal to x plus 1. If I take the 1 to the other side, it will be x plus 1. So x plus 1 squared. It's squared because at the turning point, we have two x values which happen to be -1. And then the other intercept is x minus 3. Okay, so if I were to multiply that out, well, how would that look? I have x squared plus 2x plus x, and all of that is multiplied by x minus 3. Okay, I'm just gonna pause because my son is here. Okay, sorry about that. He decided he's gonna be with me, so please bear with me. So if I multiply it out, everything, okay, so I'm gonna get x cubed, and then that will be plus 2x, plus 2x squared, and then plus x. All right, okay, then we're gonna have, where am I? X cubed plus 2x squared, and then plus x. Okay, and then we're gonna multiply by -3x squared, -6x, and -3. Okay, so we already have 3. That's a good sign. Now, and we have x squared, x cubed, so that's good. Now let us see with the other ones. So I have x cubed minus 3x squared plus 2x squared will be -x squared. Okay, things are looking good. Minus 6 plus x, that will be minus 5x. So yeah, we have the equation, ladies and gents, and that's it. Okay, so that was 9.1. We showed that indeed the equation is that. Then 9.2, it says calculate the coordinates of n. So n is a turning point. We already have the coordinates of m, so let's get the coordinates of n. And by doing so, we know that the gradient at the turning point is equal to 0. So I will then make the equation equal to 0. So if I take the first derivative, that would be 3x squared minus 2x minus 5 is equal to 0. Okay, yeah. I'm going to use the quadratic formula because, yeah, I don't want to keep guessing what the factors are. I don't want to waste time. So I have minus 2 plus minus, then I have negative 2 squared minus 4ac. So a is 3 and c is minus 5. And this is all over 2a, which is 2 times 3. We're going to plug this in the calculator so that we get x is equal to something or x is equal to something. One of the answers we should get should be negative 1. If we don't get x is equal to negative 1, then something was completely wrong. Okay, so I have negative and negative is positive, and that's going to be 4 minus 4 times 3 times negative 5 all over 6. So I get 1,6666. That can be translated as what? Let me just write 1,67. Okay, I think that's the same as what? 7 over 6? Yeah, 7 over 6. I think I prefer fractions. Okay, and then if I go back to that equation, let me just remove all of this. Ah, man, I have to type it again. Yeah, that sucks. Okay, so I have 2 minus square root 4 minus 12 times negative 5 all over 6. And then we have negative 1. Yeah, so we are in the right direction. Okay, so we know now n has a x value of 7 over 6. Now we need to get the y value. Okay, because they wanted the coordinates of n and not exactly just the x value. So we're going to take 7 over 6 and we're going to substitute it in the formula that we have. So 7 over 6 cubed minus 7 over 6 squared minus 5 times 7 over 6 and then minus 3. So we have 7 over 6 squared, 7 over 6 cubed, 7 over 6 cubed minus 7 over 6 squared over 6 squared minus 5. What makes calculations go easier, if you got 7 over 6, I would suggest that you store it somewhere so that you don't have to type it all the time. Alright, so we are getting a negative y value, which makes sense. So that will give us negative 8,61, which can be written as negative 1859 over 216. It's really up to you which you're going to use, but I think ultimately when I write down the coordinate of n, I'm just going to say it is 1,67 and negative 8,61 instead of using the fractions. It's really up to you. Alright, so we're done with 9.2. Now 9.3.1, it says, for which values of x will the function be smaller than 0? Okay, I'm gonna try to, I see I can't really edit this PDF. It's all good. So I'm just gonna redraw this function and then, yeah, we'll see what we do. Okay, let me pause, draw it quickly, and then we'll continue. Alright, I've drawn the function, so let's start answering. Okay, it says, for which values of x will the function be smaller than 0. So if it says f of x is smaller than 0, it means we're looking at the y values of the f function where they are less than 0, okay? And what we can do, okay, I see here, I have negative, right? Then I get to m and y is 0. And then I go here, I still have negative values, negative, 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 until I get to 3, where my value for y is 0. Okay, so basically I have negative values of y from negative infinity, okay, up until 3. So that is the cutoff. The cutoff is 3. So when I write down my answer, I would say x is an element of negative infinity, because it does stretch all the way to negative infinity, okay, and it goes all the way to the value of 3, but 3 is not included in this case because 3 is equal to 0. All right, so that is how I would write it. Or you could simply say x smaller than 3. Okay, x is smaller than 3. You could put that as your answer. Okay, then 9.3.2 says the values of x where f will be increasing. So where is f increasing? F is increasing up until we get to m, so all the way from negative infinity to 0. Then it starts decreasing in this region. Okay, it's going down. And then it starts increasing again after we pass the turning point. And it goes, starts increasing all the way up until infinity. Okay, so what can we say? We can say that f is increasing from negative infinity up until 7 over 6, and then it starts increasing again from 7 over 6 up until infinity. Okay, or you could say, or how can we put it? We can say, no, what am I saying? Please don't mind me. X is increasing from negative infinity to negative 1. Oh my goodness, there it is. I just drew it out. Okay, and then it's increasing again from 7 over 6 till infinity. Okay, sorry about that. And then that's it. That's where I would put my answer. All right, and then the last one where it says find the values of x, for which values of x will f be concave up. Okay, so if it were concave up, it's pretty much like this. Okay, if it's concave down, then it would be that. So concave down is this region, okay, but we are looking for concave up. Okay, it's concave up in this region over here. But now, what do we call that point where it transitions from concave down to concave up? Yes, it's called the point of inflection. Thank you. So we need to first determine what the point of inflection is, and we see according to the mark allocation that this is 3 marks, so they know we need to calculate something. So to get the point of inflection, I need to get the second derivative. Okay, so what was the first derivative? The first derivative was 3x squared. Just gonna copy that one so that we don't have to go up and down. Okay, so the first derivative was that. Now the second derivative will be 6x minus 2, and we make it equal to 0 when we want to get the point of inflection. All right, and so we have 6x is equal to 2, and then x is equal to 2 over 6, which is just a third. All right, and that makes sense. I mean, if n is 1 and 1/6, then yeah, the point of inflection, which is probably somewhere here, it makes sense that the x value is a third. Okay, so now we know. So if we get the values of x where it's concave up, it will start where x is a third and go all the way to infinity. Okay, so we have a third, x, then infinity. Okay, we don't include the third. Yeah. Okay, or we can just say x is an element of a third, and it goes all the way to infinity. All right, that is when it starts becoming concave up. All right, and then the last question, while I shut up my son because he's making noise with his games. Sorry. Alrighty, now 9.4 says determine the maximum vertical distance between the graphs of f and f prime in the interval -1 until 0. So how would we sketch f prime? If you want to know how a graph transitions from a cubic to a parabolic, please do watch my video where I do functions and address the cubic functions. Okay, so basically the turning point of a cubic function is the x-intercept of the parabolic function. Okay, so even here I just go all the way up, so that is the x-intercept. Okay, and then the point of inflection of the cubic function is the turning point of a parabolic function. Since we have a positive cubic function, we're also going to have a positive quadratic function, so a smiley face parabola basically. And then so there we have the point of inflection, which is a third. That is going to be the turning point of the function. So I don't really know what the y value is for the turning point. Okay, but yeah, basically your parabolic function is gonna look something like that. Okay, not drawn to scale, please, so bear with me here. Okay, so that's basically f prime. All right, and if they wanted you to draw the function of when you do a second derivative, that will just basically be a straight line going up from left to right. Okay, so now we need to determine the maximum vertical distance between the graphs of f. So if you have a look between -1, so this is -1, right, at this point here, up until 0, that is really our point of our range, where we are interested in. Okay, and if I look here, I mean, you have a small distance between the functions, and but somewhere in the middle here we actually have the maximum vertical distance. Now another thing, as soon as they say maximum, in my mind I'm thinking we need to get the first derivative and make it equal to 0 and solve. Okay, but what equation are we going to use? I can see that on top I actually have my not f prime, I have my function fx, right? And then at the bottom I have f prime. Okay, so for me to get the maximum vertical distance, so maximum vertical distance, I will then say it is f of x minus f prime. Okay, and we have those two equations. I'm just gonna say maximum distance, MD. Okay, MVD, maximum vertical distance. Yeah, I think let's say that MVD. So f of x, we have it as x cubed minus x squared minus 5x minus 3, and then f prime x, we had it as 3x squared minus 2x minus 5. So 3x squared minus 2x minus 5. Oh, I didn't actually have to go look for it. I could have just worked it out here. All right, and then let's just simplify this equation. Okay, because now we're actually, we want to get what this MVD equation is. And then we're gonna get the first derivative, substitute that x value into the original equation, which we are forming right now, and then we're gonna get the distance, that is y. So I have x cubed minus x squared minus 5x minus 3. I'm removing the brackets, so I have minus 3x squared. I have 2x, positive 2x, and then I have positive 5. So now I can actually work it out. Okay, x cubed is alone. I have minus x squared minus 3x squared, so minus 4x squared, and then minus 5x plus 2x is going to be minus 3x, and then minus 3 plus 5, that will be 2. So this is my equation for the maximum vertical distance, MVD, not MV tutors. Okay, so now I am going to get, the first derivative, all right, because that's how I'm going to determine the maximum, by making it equal to 0, the first derivative equal to 0. So I have 3x squared minus 8x minus 3 is equal to 0. And then I am going to use the quadratic formula. Okay, minus 8 plus minus, so I have minus 8 squared. Is it b squared minus 4ac? Okay, minus 4ac. And that would be all over 2a. Okay, let's pop up our calculators and work it out. So I have 8 plus square root of 64 minus 12 times negative 3 all over 6. I'm just multiplying out. Okay, so the first value is x is equal to 3, or just gonna get the negative alternative, and that is negative 1 over 3. So x is equal to negative 1 over 3. So let us see, guys. Back to our sketch. Which one would be applicable, 3 or negative a third? I believe it will be negative a third, because positive 3 is there. Okay, and at that point in time, that's not what we're looking at. We're looking at the range from negative 1 to 0. So we're going to go with negative a third. Okay, so we're not going to look at this. This is what we're going for. After getting this x value, we are substituting it in our MVD equation. Okay, and what is our MVD equation? It's x cubed, so this will be negative a third cubed, minus 4 negative a third squared, minus 3 negative a third x, negative a third, and then plus 2. Okay, and then we can plug this in the calculator. Okay, so negative a third cubed, okay, and then we are subtracting 4 negative a third squared, and then we are subtracting 3 times negative a third. Okay, and then we are adding 2. Okay, so that is 68 over 27. I just want to see what the decimal answer is. Okay, so that is 2,52. And does that make sense? Well, yeah, it kind of does. But again, I did not draw this to scale, okay? For all we know, this parabola has shifted up, whatever, but I did not draw this to scale. So I can't really compare much. I'll just have to trust, that my answer is correct. So yeah, the vertical distance, or the maximum vertical distance, would be 2,52 units. because I don't know what they're using here. Is it meters? Is it centimeters? Is it millimeters? Is it inches? So 2,52 units. And that concludes question 9. All right, I hope you understood. And if you didn't, please comment below so that I can help you out and see how we can work this. Just a reminder, please don't forget to like our videos and subscribe to our channels and spread the word. Thank you. Hello everyone, and we are finally there. Question 10. All right, thank you for sticking through with me as we work this out. I hope this has been helpful. I've been making quite a few silly errors, but I'm just human. At least I saw it before publishing. But if you do notice any errors and from question 1 up until now, please do inform a sister so that I can correct myself. Okay. And if there's anything you don't understand, please comment down below and I will try to assist as best as I can. All right, so question 10. This is the probability section and counting principle. It says flags from 4 African countries and 3 European countries were displayed in a row during the 2021 Olympics. Okay, so determine 10.1.1 the total number of ways in which all 7 flags from these countries could be displayed. Okay, so I'm gonna ask you, between 7 factorial and 7 to the power 7, which one would we go with? Well, let me tell you, there are 7 options available, ne? Okay, and you can't have repetition because there's only one flag. Let's say from the 4 African countries, you only have a certain country, you can only use that one flag. So this will not be an option because that is when you consider repetition. Okay, if there is no repetition, then you consider the 7 factorial, because once you have used the first flag, you're left with 6. Once you use the second one, you're left with 5, and so on and so forth. Okay, so this would be the options you would have, and that is purely 7 factorial. If we work that out in the calculator, 7 factorial, that would be 5,040. Okay, I hope that was clear. And then 10.1.2, it says the probability that the flags from the African countries were displayed next to each other. So again, we have 7 open spaces. Then the 4 were displayed next to each other. So they could have taken the first 4 spots, or they could have taken the last 4 spots, or they could have taken the middle spot, or whatever other combination they would have taken. Okay, so yeah, we can basically do that. Okay, so I'm just going to assume they're going to take the first 4 spots and then we're left with 3 spots. So how do we get the answer? Basically, this is one option we're looking at. This is the second option, the third and the fourth. So they can be jumbled up and rearranged, okay? But basically, that's where we get the first 4 factorial. Then, within this one, the different flags can also be placed anyway and anyhow. So, yeah. And therefore, that's why we also have another 4 factorial. And if we were to work that out, so we have 4 factorial times 4 factorial, and that's 576. That's your answer. Okay, and then we get to 10.2. We're almost there, guys. Almost there. So A and B are 2 independent events. Okay, if I hear independent, I already think about this equation for independence. Okay, that's where you have probability of A times probability of B. Then they tell me what the probability of A is, which is 0.4, and the probability of A or B is equal to 0.88. Okay, if I think about that equation, A or B, Well, it would be the probability of A plus the probability of B minus the probability of A and B, okay? And that is for when we have events that are not mutually exclusive. If the events were mutually exclusive, this third or this last section would be kicked out. Okay, so we need to calculate the probability of B. Okay, so what I'm going to do, I am going to put in the information that I know. So the probability of A or B, I've been told, is 0.88. The probability of A is 0.4. The probability of B is what I'm calculating. And then the probability of A and B is actually this over here. So probability of A times the probability of B. Oh, and I know what the probability of A is 0.4. So anyway, let me just say 0.88 minus 0.4 leaves me with the probability of B minus 0.4 probability of B. So 0.88 minus 4, that is going to be 0.48, and 1 minus 0.4, that will be 0.6. Right? And then if I now get, let's just do this, if I divide by 0.6 both sides, I will have that the probability of B is going to be equal to 0.48 divided by 0.6. Okay, that's 4 over 5, which is the same as 0.8. And yeah, guys, that's basically the answer. Okay, so we are done with 10.2. And now we're headed over to 10.3, and then we are done with this paper. Alright, so here it says there are 120 passengers on board an airplane. Okay, passengers have a choice between a meat sandwich or a cheese sandwich. But more passengers will choose a meat sandwich, which makes sense. Who would go for cheese only? Well, we want meat. There are only 120 sandwiches available to choose from, of course, because there are 120 passengers. And the probability that the first passenger chooses a meat sandwich and a second passenger chooses a cheese sandwich is 18 over 85. Calculate the probability that the first passenger will choose a cheese sandwich. I mean, what is the likelihood? So what am I going to use here? I am leaning towards a tree diagram, okay, because here we have dependent event and a dependent event, because once, okay, let's say you have a hostess who has a box full of all these sandwiches, okay. Sandwiches are all in there, the 120, and she's walking around and she's carrying them, and it's like offering to people, would you like cheese, would you like meat? So as soon as one goes out, you're left with 119, and that's why I'm saying these events are dependent on each other. Okay, the next probability is dependent on the sandwich that was taken out before, and so I will go with the tree diagram. Okay, now we have meat and we have cheese, so I'm going to say let the meat be X and let the cheese sandwich be Y. Okay, and I know at the end that X plus Y, it gives me 120 because I have 120 sandwiches. All right, so let us see, how are we going to solve this? Okay, so firstly, the probability that meat would be chosen is however much. Okay, so that's the first person. So the hostess comes in, 120 sandwiches, gives it to the first one who wanted meat. Okay, and then the second one, it will depend. Will they go for cheese or will they go for meat? Okay, there's that option. So firstly, I could have gone for meat. So this is the first person that we're looking at. They can either choose meat or they can choose cheese. Okay, then the second person, from the one who chose meat, they can either choose meat or cheese. And you know, they can either choose meat or cheese. So that's the second person. First person, and we have second person. Okay, so let's see. We said that meat is X, okay, and cheese is Y. So if the first person is about to take meat, they have X options to choose from the 120. If this person were to take cheese, they have Y options to choose from the 120. So after this person has chosen meat, let's say the first person has chosen meat, if they take that meat sandwich away, we are left with 119. Okay, and also we no longer have X options available. We have X minus 1 options available. Oh, sorry, this is for meat. Let me just not confuse myself as I work this out. I'm thinking of a meat person. So the first person chose meat, then there are 119 left. And the second person, if they still want meat, there'll be 119 left. Okay. Now, what if the first person chose meat and then the second person decides, I'm going to take cheese? Well, we still have the same amount of, we have 119 left because the meat is already out. Okay. But I still have the total amount of cheese because the first person took out the meat, right? So I have 119 left, but I have this. I have all the cheese sandwiches left, so that's why I put Y there. All right. Now the likelihood that a person will take cheese, the first person takes a cheese sandwich, is Y over 120. All the cheese sandwiches available, so it's Y. Now, what is the likelihood that after that person takes the cheese sandwich, they will then take the meat? Well, let me just put it this side. I have 119 left, okay? But I still have a total of the meat because the first person took cheese. So I still have a total of the meat, right? And then for the cheese sandwich, well, the first person took 1. So I'm left with 119. If the second person also takes the cheese sandwich, it will be Y minus 1. Okay, I hope that makes sense. Now they told us that the probability that the first passenger chooses a meat sandwich, so they choose meat, okay? And then a second passenger chooses a cheese sandwich. Okay, meaning we have X over 120 multiplied by Y over 119. That is 18 over 85. Okay, so that's the probability of the meat and the cheese following each other in that order. So that is 18 over 85. And from this, I am going to work out what X and Y is. Okay, X being the meat and Y being the cheese. So here I have 2 unknowns and 1 equation. Okay, if I have 1 equation, I need to have 1 unknown. So remember I said that the meat plus the cheese equal to 120. So I can say then the cheese is 120 minus X. Or I could have said the meat is 120 minus Y. It's really up to you which one you choose. I will go with changing X into Y. Why not? Okay, so I then have 120 minus Y over 120, and this value I calculated with Y over 119. Okay, and then if I multiply this out, I have negative Y squared and positive 120Y. Okay, this is all equal to 18 over 85. In the denominator, I have 120 multiplied by 119, and that is equal to 18 over 85. Okay, so minus Y squared plus 120Y is equal to 18 over 85 multiplied by 120 multiplied by 119. So I think at this point I need to get what that value is. So I have 18 over 85 multiplied by 120 multiplied by 119. And oh, okay, so it's 3024. Alright, so I have minus y squared plus 120y. I'm going to take that 3024 to the left side of the equation sign. So negative 3024 is equal to 0. And then if I just work, if I divide everything by negative, I have y squared minus 120y plus 3024 is equal to 0. So I'm going to definitely use the quadratic formula because I am not about to look for the factors of 3024 to see what will give me 120. That is too laborious. Okay, so I have y is equal to that plus minus 120 squared minus 4 AC 3024. Okay, all of that under the square root and all of that over 2a. Okay, so I have 120 plus 120 squared minus 4 times 1 times 3024 all over 2, and I get 84. So y is equal to 84, or if I get the negative, y is equal to 36. Y is equal to 36. Okay, so my cheese sandwiches, okay, so they told us that a lot of passengers are definitely going to go with the meat. Okay, so in that case, I don't know if you realize, but if you were to add 84 and 36, we actually get 120. So yeah, we can see here which one is cheese, which one is meat. I would say that the meat is actually 84. There are 84 sandwiches of meat. Okay, so that is basically our x. And then there are 36 sandwiches of cheese, or 36 cheese sandwich. Okay, because that is the least. Okay, sandwich. Oof. My handwriting there. A sandwich with the H. No, just sandwich. Okay, so we have 84 meat sandwiches and 36 cheese sandwiches. So if we were to look at our tree diagram over there, now I forgot, what are we actually working on? It says calculate the probability that the first passenger will choose a cheese sandwich. Okay, so if we have a look again at our tree diagram, the first might choose meat, the second might choose cheese. Okay, meat and cheese. We're not looking at that now. We are very interested in this path over here, because it says calculate the probability that the first passenger will choose a cheese. So if they choose cheese and choose meat, the second person chooses meat, it doesn't matter. The first person chose cheese. That's what they're asking. Even here, if they chose cheese and then the second person chooses cheese, it also doesn't matter. The first person chose cheese. Okay, so basically what we want, we'll be calculating the probability of CM and CC. Cheese and meat, cheese and cheese. Okay, and we know, all right, so we said that x is equal to 84, and that's the meat, right? So this was basically 84 over 120, and this was 36 over 120. If they went with meat, that would have been 83 over 119. They will still have the same amount of cheese. Okay, but we're not really interested in the top part, we're interested in the bottom part. So if they chose cheese first, we have 36. If they chose meat, we still have 84 over 120. If they chose cheese first and then cheese later, well, we'll have one less of the cheese, so it is 135. So basically now the probability, okay, probability that they will choose cheese first will be equal to 36 over 120 times 84. Oh my goodness. So my mistake. Okay. So this should be 119 because we've already taken one out. It can't still be 120. Okay, apologies for that. We have 119, 119, 119. So we have 84 over 119 and then plus 36 over 120 times 35 over 119. And we can finally work this out. Yo, my hands are even tired. We've been at this. Okay, I'm going to take out the common factor here. 36 over 120, I have 84 plus the 35 over 119. Okay, so I took out this common factor. I was left with this plus that. They have the same denominator, hence I'm saying 84 over 35. Oh, 84 plus 35, sorry. So now we have 36 over 120 and we are multiplying it with 84 plus 35 over 119, and our answer then becomes 0.3 or 3 over 10. Okay, so that is the probability, 3 over 10 or 0.3 or 30%. So there's a 30% chance that the first person is going to take the cheese sandwich. Okay, and we are done. We're done with this paper. I hope you learned a thing or two. I hope that will prepare you in matric for your junior exams. If you have questions, comments, please do comment down below. Suggestions, criticism, to help us to be better, please do put it in the comment section. Otherwise, don't forget to like our videos, subscribe to our channel, tell a friend, a classmate. Don't keep the information to yourself. Alright, thank you and bye.